Hello everyone, let's look at some numericals based on simple harmonic motion. Example 1 says a particle, or question says if a particle executes simple harmonic motion of period 4 seconds, here period means time period, and amplitude 2 centimeter, find. There are two subparts to the question. Subpart 1 is find its maximum velocity and also velocity at half the maximum displacement. So here let's write the data given first. So what is given here is, it says that the time period, which is capital T, is given as 4 seconds, and amplitude, which is capital A, given as 2 centimeter. Question says find the maximum velocity. Recall that velocity at any point is given as omega into under root of a square minus y square. Velocity is maximum if y is equal to 0. That implies v maximum is a into omega. Putting it back here, a is given as 2 centimeter, so 2 into 10 power minus 2 in terms of meter, and omega is not given here, rather time period is given. We know that omega is equal to 2 pi by capital T. So we put it back here, it becomes 2 into pi into capital T, which is 4 seconds. So there is 4 in the numerator and this gets cancelled. So what we get from here is that V maximum is equal to pi into 10 power 2 meter per second, which is 3.14 centimeter per second. So this is what is the velocity, the mean position, which is V maximum. Second part says find the velocity at half the maximum displacement. So if you use the same formula here, if you use this formula only, it says find the velocity at half the maximum displacement. It means that y, which is the displacement in this equation, is half of maximum displacement. Maximum displacement is called as capital A. It becomes a by 2. Therefore, when you put it back here, v is equal to omega into under root of a square minus y here is a by 2 whole square, and that is equal to, it will be omega into, it's a square minus a square by 4, and if you pull out a square, it becomes omega into 3a square by 4, the whole under root. If you remove the sign, then what you get here would be omega into a, because a root of a square becomes a, and root of 4 becomes 2 into root 3. But omega into a is we found it earlier, which is 3.14. That is equal to 3.14 in terms of centimeter. So centimeter into root 3 by 2, and that is equal to 2.72 centimeter per second, because this omega into a is in terms of centimeter per second. Verify and see the answer. The answer will not change. There's no point in solving it from here because it's not arithmetic class. So verify from and see it, what would the answer would be. Example 2 says the acceleration of a particle executing simple harmonic motion is 12 centimeter per second square, because it is the acceleration at a distance of 3 centimeter from the mean position. Question says calculate its time period. So acceleration formula, which is a, was given as minus omega square into y. The question says the acceleration of the particle is 12 centimeter per second square at a distance of 3 centimeter from the mean position. Means when you put y is equal to 3 centimeter, in that case a becomes 12 centimeter per second square. Putting it back here, is 12 into 10 power minus 2 because it is in terms of centimeter. It is equal to, we can drop the minus sign because minus sign just shows that the acceleration is opposite to displacement. So in terms of magnitude, you can say A is equal to just omega square into y in terms of its magnitude. So putting that here, we get it as omega square into y is 3 centimeter, which is 3 into 10 power minus 2. So 3 ones are 3 fours are, and then 10 power minus 2 gets cancelled. This would lead us to the form 4 is equal to omega square. Therefore, omega would be root of 4, which is 2 radian per second. But here what we want is the time period. We know that time period is equal to 2 pi by omega. So it is 2 into pi is 3.14, omega is 2. From this 2 and 2 gets cancelled. Therefore, what we get here is the time period is equal to 3.14. What is the time period? Example 3 says a body is vibrating with simple harmonic motion with amplitude 15 centimeter and frequency 4 hertz. There are two parts to the question. First part says calculate the maximum acceleration. The second part is the velocity when the displacement is 10 centimeter. So let's write data given. The amplitude is given as 15 centimeter, is 15 into 10 power minus 2 meter. The frequency is given as 4 hertz. Question says find the maximum acceleration. We know that A maximum is equal to minus of omega square into A. But if you just take its magnitude, then A maximum mod is equal to omega square into A. Omega is not given directly here, but we know that omega is 2 into pi into f. F is 4 here, so it becomes 8 into pi because f is 4 hertz. It becomes 8 pi the whole square. A is 10 into 10 power minus 2. This becomes 64 pi square into 15 into 10 power minus 2. 64 into pi square would be around 6. 31.65 into 10 into 10 power minus 2, that is equal to, will be 9474.82 into 10 power minus 2. Please verify this and see. That is equal to 94.75 into 10 power minus 2. No, 10 power minus 2. We have pulled out the power here. What we get? Meter per second square. That is what is A maximum. The first part of the question. Second part says find the velocity when the displacement is 10 seconds. So says find the velocity when displacement is 10 seconds. We know the velocity is given as the velocity at any point is given as omega into under root of a square minus y square. Here y is 10 centimeter and a is already known as 15 centimeter. Put back here, v is equal to omega was 2 pi f, which was 8 to pi under root of 15 into 10 power minus 2 the whole square minus 10 into 10 power minus 2 the whole square. From these two terms, 10 power minus 2 whole square is common. Comes out, it becomes 10 power minus 2. So it is 8 pi to be 225 minus 100 into 10 power minus 2. That is equal to, it is 8 pi into root 125 into 10 power minus 2, and root 125 is equal to is 8 pi into 11.18 into 10 power minus 2. Solve it, we get it as 2.81 meter per second. This is the velocity at a distance of 10 centimeter from the mean position. Example 4 says the maximum velocity of a particle executing simple harmonic motion is 100 centimeter per second, and the maximum acceleration is given as 157 centimeter per second square. Observe that velocity and acceleration in terms of centimeter. Determine the time period of motion of the particle. So here what is given is, it says maximum velocity, which is V max, is given as 100 centimeter per second, which is same as 1 meter per second. A maximum given as 157 centimeter per second square is equal to 1.57 meter per second square. The question says find its time period. So let's recall what is V maximum. V maximum is equal to A into omega, and then A maximum in terms of magnitude alone, that will be A into omega square. We divide A maximum by V maximum, we divide A maximum mod of it by V maximum, that is equal to A omega square by A into omega. From this, omega gets cancelled, A gets cancelled, and this is just equal to omega. So we divide this by this, divide A maximum by V maximum here, it will be 1.57 by 1 is equal to omega. Therefore omega is equal to 1.57 radian per second. But what we wanted is time period. We know that time period is equal to 2 pi by omega. It will be 2 into 3.14 by 1.57. This is approximately equal to 4 seconds. This is what is the time period. Example 5 says the velocity of a particle executing simple harmonic motion is 16 centimeter per second at a distance of 8 centimeter, and it is 8 centimeter per second at a distance of 12 centimeter from the mean position. Question says determine the amplitude of the motion. Now here the velocity of the particle is given at two positions, at a distance of 8 centimeter and at a distance of 12 centimeter. So we need to find what is the amplitude in this case. So recall the formula for velocity at any point of time. The velocity at any point of time, which is V, is given as omega into under root of a square minus y square. So if we take the first case, then in that case the velocity is 16 centimeter per second. So it becomes 16 into 10 power minus 2 is equal to omega into a square is unknown minus y square. Here y square would be 8 centimeter square, and it's 8 centimeter, it becomes square here. So to avoid the multiples, we'll just take the whole thing in terms of centimeter only, so that we need not worry about the multiple of 10 power minus 2. We'll just write it as 16. But keep in mind that velocity and displacement contain centimeter, not meter. Will be a square minus 8 square. Keep in mind that if you're taking the displacement in terms of centimeter, in that case even a should be in centimeter only, because we can't subtract centimeters meter square, it becomes difficult. So both v and y would be in centimeter and also a would be in centimeter only. Otherwise it becomes difficult to carry the powers here. The second condition is the velocity becomes 8 centimeter per second. So it becomes 8 is equal to omega into a square minus, it becomes 8 centimeter per second at a distance of 12 centimeter. It becomes 12 square. If you divide these two equations, then from these two equations omega gets cancelled, so it becomes 8 ones are 8, 2s are plus 8 2s are 1s are here. Finally what we get from this is that 2 is equal, if we cross multiply from here, let's bring this term on top, then 2 into under root of a square minus 144 is equal to under root of a square minus 64. Let's square this now. So 4 a square minus 144 is equal to a square minus 64. Let's take 4 inside. So 4a square minus 144 into 4 would be equal to be 576. That is equal to a square minus 64. Let's bring this a square on this side and take this side. Then that would leave us with 3a square, because 4a square minus a square will be 3a square, is equal to 576 minus 64, and that would leave us with 3a square is equal to 512. A square is equal to 512 by 3, that will be around 170.67. We want a, so a is obtained by squaring this term, 170.7 is equal to around 13.06. Remember the whole thing is a centimeter, so 13.06 centimeter. This is the required answer.